not a great day for me is unfortunately something that I'm not able to share with all of you, because some things must remain private. Some things must remain private. They cannot simply be shared with any random person. And this is one of those things, so I apologize in advance if I'm not my usual bubbly self for this board repair video, because at this point in time, I am particularly bummed and feel particularly stupid. And I realize that I just kind of earned feeling stupid, and I just have to deal with it. Realizing that you're an idiot is kind of something that you just have to grieve. You know, once you figure out that you did something stupid and you have to deal with it, it's just kind of the grieving process of, man, you're really that dumb. Alright. So, what we're going to do here is figure out what's going on with this MacBook. So it's taking 12 milliamps. That's a strange number. You don't get a green light, so I'm guessing PP3V42 is gone. First thing I'm going to do is unplug everything here and see what's going on there. I'm going to unplug, and I'm going to take everything out of this machine and see what's going on with it. This is an 820-3332. It's humbling to get reminders every now and then that you're not as stupid as you thought you were. You're actually considerably stupider. It is humbling. I'll give it that. I think, oh, I thought I was an idiot, but in fact, I'm a gigantic idiot. Check for the solder bridges. They're 104 in New York City for sale. Okay, that made me laugh. I needed that today. Every now and then you learn something that just gets this cloud hanging over your head. Today be one of those days. All right. This jack, oh, son of a... You set me up. The latch over here was kind of broken off already. I don't know what app you mean, Nitrocaster. If you tell me the name of the app, I could check it out. If you say the thing we talked about, then that's in the depths of a memory hole that is long gone. That's as gone as the hair on the back of Trump's head prior to him having a transplant. That is as gone as the American public's trust in government and the media. That is as gone as the days of not having a budget deficit at the federal level. Okay, so we have the MacBook, and now we can see if anything has changed. Still 12 milliamps. Alright, so what are the things that we usually go over on these MacBooks? I'm kind of... Alright. .42 volts. Alright, we got that. PP342 is there. PP bus is 4 of... Oh, you can't see that. So PP342, which is the power rail required for the one-wire circuit to work, is 3.42 volts. The one-wire circuit is what's going to give us a light in the charger. We don't have a light in the charger right now. And PP bus G3 hot, the next rail, is 4 volts. Alright, so the green light can be controlled by the ISL6259, which shoots out SMC BCACOK to the one-wire circuit to allow the green light to turn on. And the ISL6259 is also the chip responsible for PP bus being 12.5 volts instead of 4 volts. So what do I mean by that? Well, that's a great question. I would suggest that you watch any of my one-wire videos to understand the one-wire circuit, so you understand what I mean with the green light on the charger. Let's take a look at that. So this is the charge port is over here, right? So this is my charger. See, it plugs in right over here. So we're going to take a look at that on the schematic in the board view. I'm going to walk you through that here. J6900. Go to the schematic. Full screen the schematic. So, how does this work? Well, the adapter, before it puts out 18 volts and before everything really works the way it's supposed to, what happens is adapter sends this signal, needs to speak. PP of that board is short. It says Pedro. Nah, because the PP of this board is 4 volts, so that's not a short circuit. You know what it is. I'll give you a hint, Pedro. It's eyes. When you look at it, it looks like eyes in the microscope. And I will show you that in just a moment. But so adapter sense needs to speak to the system management controller on the sys1 wire line. Sys1 wire, if you take a look, is going to go to the SMC. See? It's a bidirectional data line to U4900, which is the system management controller, SMC. Now, in order for this chip to do its job and allow the adapter sense to speak to the SMC, this chip needs to be on. For this chip to be on, it needs to be getting power, VCC pin. This chip to get power, this logic gate needs to work. This is how it's going to pass PP342_G3 hot to U6900. And this logic gate's not going to work unless SMC BCACOK is present. So I need PP342 to be present because this one-wire circuit, this whole circuit that allows the charger to speak to the computer, is not going to be powered if this is not there. But this also needs SMC BCACOK to be present, right? So we have no green light, so this circuit's not working. Now, the next thing that I noticed is that PP bus G3 hot is also not present. Okay, so SMC BCACOK turns into charger ACOK, which is over here at the ISL6259. Now, the ISL6259 is responsible for PP bus G3 hot, which is low. So we have two problems on the computer right now. So the first one is that we don't have a green light. And the second is that this power rail, PP bus G3 hot, is 4 volts instead of its standard 12.5. So we have two problems that both come back to this same chip. So I'm not going to try to diagnose these problems separately. I'm going to look at this chip area because this is probably where my problem is. So where is U7000? Well, that's a great question. So we're going to take a look at CD3215. Or this machine doesn't even have CD3215s. Watch my videos. Anyway, so U7000 is right over here. So then when I put this under the microscope camera, what you're going to see, and what I know Pedro would have known by now from watching all this stuff, I'm confident Pedro knew this before he even logged onto the stream, is that it's not a PP bus short. Rather, it's the eyes. Does anybody see the eyes? I'm going to give you a chance before I point it out. Where are the eyes? Does anybody see the eyes? I'm going to unplug the power supply so that I can point on the board. Top two resistors. Very good, yummy steak. Now, these two resistors are supposed to be about 10 ohms each. And if we measure this in ohms mode, that ain't 10 ohms, man. That ain't 10 ohms. Now, if we were to replace those resistors, it wouldn't even matter because, as you can see over here, shorted to ground. So this over here is shorted to ground. And it's shorted to ground through the ISL 625.9. So what is that area? And what is it for? Another great question. This is a current sensing circuit. So, take a look on the schematic. Let's get a big view again. Nice big view over here, schematic. This is a circuit that's going to take the 18 volts from the charger, and it's going to turn it into 12.5 volts for the system. This is how we get the battery to charge from a power adapter. The power adapter provides 18.5 volts. The battery is going to be charged at 12.56 volts, and that's how this works. So, this over here, this is a transistor that's going to keep reverse current from going through. So let's say that my battery is plugged in and it sees my charger as a load. You don't want the battery to be able to go up through here and charge the charger. That's ridiculous. I don't know if any of you have ever had a really cheap 18650 charger where when you plug it in to the wall with the 18650, the light turns red to tell you it's charging. But then when you unplug it from the wall and install the battery in there, the light is still on because there's no reverse current protection. So the battery is then, quote, charging the charger. It's ridiculous. So this is there to keep that from happening. Then you have this. This is a current sense resistor. So this chip is responsible for creating this power rail over here. But it wants to know how much current is this using. But this chip is out of the stream, so it can't tell. It's kind of like you trying to tell how hard water is flowing without your hands in the stream. You would need your hand in the stream to be able to measure. The same thing with the chip. It's not in the stream. So this is where the current is going to be going through, because it goes out here and then turns into 12.5 volts. So this is going to be 18 volts coming through here. This is a transistor. It's going to turn, it's like a switch. It turns on, off, on, off, on, off. 18, 0, 18, 0, 18, 0. That's going to get evened out into 12.5 volts when it goes through this coil. The combination of a pulse of 18 and then 0, and then 18 and then 0. This chip controls that happening. Now it's going to want to know how much current is going through it, but it can't because it's not in the stream. So what it does is it's going to put its hands in the stream, or in this case, it's going to put a resistor there. Now this resistor is going to have a different voltage at the top and the bottom, and that voltage difference is going to be proportional to the amount of current that is going through. So let's say that the system is taking thousands of amps. You're probably going to, I'm just making shit up here, but like if it was thousands of amps, maybe you have 18 volts up here and 15 volts down here. Whereas if it was only taking a quarter of an amp, you have 18 volts up here and 17.99999 volts down here. And the ISL 625.9 is going to check the voltage at the top or the bottom, and then it's going to determine how much amperage the system is using. And it has this 10 ohm resistor in between. Now, the 10 ohm resistor in between is dead. And when I checked on this end of the resistor, it was short-circuited to ground, which means our U7000 or ISL 625.9 was destroyed. So what we're going to do here to fix it is I'm not just going to replace the resistors, because replacing the resistors is going to result in them blowing immediately right after I'm done, because the ISL 625.9 is also shorted to ground. We are going to replace those two resistors, but also replace the ISL 625.9 that failed in this manner. Someone asked, are your LCD screens the same quality as Apple's? Depends on what it is you're looking for. So, for iPhones, they're aftermarket. We used to be able to get originals. Those days are long gone. For laptops, we used to be able to get the LCD cell by itself, brand new. Now we're like stuck with used display assemblies and shit because it's hard to really find anything anymore. It really depends. Like, it depends on the... So let's say you're talking about a MacBook Air from like an A1466. We use the LP133WD1SJ A1, which is pretty much the same shit that Apple had in there. So it is going to look the same because it's the same model. If it's a MacBook Air, we use 11-inch. We use the same B116XW05V0 Apple used. It's going to look the same. It's the same shit that they used. For other models, it's not as easy. So it really depends on the year and the model. You're getting soft in the flux. Put some more, someone says. Maybe I am, Pedro. Maybe I am. And thank you very much for that. I really appreciate that. Maybe I should put some more flux. I hope your business is doing well, Pedro. I hope you're doing well as well. Well, check it out, Nitrocaster. Thanks for the suggestion of that app. Alright, so I'm just going to heat this up. Iced Tea Junkie, the question there is, how long did it take you to get to a skill of intuition and pinpointing problems that it became commercially viable? A really long time, because I'm not very smart. Yeah, a really long time. Like, I set out to start doing this in 2009. It wasn't even until like 2011 that I had replaced a backlight fuse. Yeah, that's like that's really shitty. And then there's the. It wasn't until like 2014 that I was good enough to do even the more difficult ones in house. That was like late. So like it's a long time. And again, when you look at it, even my worst students actually learned it much quicker than I did, because I'm not very smart. But what I make up for in not being smart, I think I make up for the not being smart by simply choosing to focus on it at the expense of many other things until I learned it. Like what I lacked in intelligence, I just kind of made up for, and I don't really have a problem experimenting until 4 a.m. every single day and failing over and over and over again and feeling really stupid because I failed over and over and over again and fail, almost want to cry, fail again, almost want to cry again, keep doing it, and then someday, you got something. Okay, you got a teeny tiny thing. You barely got even anything, but that's more than nothing. Look. Improvement. And then that's the encouragement to try again. And again. And again. And again. And one of the things that I try to do here is I try to kind of go through the issues and share it, because it would be cool if other people were able to take part in the thing that I enjoy and that I find fun and that I was able to eventually learn for myself. But yeah, it took me a really long time. It took an embarrassingly long amount of time. But it's fun to be good at something. I'll say that. Like, it's fun to be good enough at something that you can just figure out and pinpoint things and know it like the back of your hands and be able to use that skill to... I really wanted to make the most of this. It's like, if I put all that time and effort into figuring this out in an idiot-proof way so that a dumbass could figure it out, I really wanted to make sure that I got the most of it. Like, How many other people can we get to bypass the experience Lewis had of feeling like a moron for years and years and years because none of it makes sense? Still got a long way to go there. Alright, so gonna give this a little bit of rapid cooling. Rapid cool! Rapid cool is my patent. Nobody can take rapid cool away from me. We are stuck at the same 18 milliamps. Alright, I should have maybe made some more cursory measurements first before I got too excited. Maybe I should share them with you. 21 ohms in current sensing, that's exactly what that's supposed to be there. This current sensing here is exactly what that's supposed to be here. $18 volts is going through there. 18 volts is going to charge your DC in. Okay, we're just going to follow this back then. So, let's figure it out. They're different chips, Manicron. It's just SMC is a system management controller, and the U7100 is it controls makes PP bus G3 hot. So they're just totally different chips with totally different points. I feel you about the lack of raw intelligence. I'm not especially smart and was broke for more than a decade and a half before I had the weight. I'm actually good at this moment and found a job in software. Keep being you. Thank you. I'm glad to hear it. Glad to hear you got somewhere. Alright, so PP bus is 12.5 volts. So at this point I think I'm just being trolled. So 12.5 volts means the SMC is doing its job. Because PP bus G3 hot would be 12.23 if the SMC was communicating something less. So now we're going to take a look at the one-wire circuit area. It's going to be these two little bastards down here. You're smarter than me if you got a job in software. NPR, of course I tested the fuse that never blows. I learned my lesson. I measure on the right side, not the left side now. No trolling myself. Alright, so we're going to check out adapter sense and sys1 wire. So pin 5 and pin 4. We're going to check out pin 5 and pin 4, because that's going to tell me what's coming in from the charger. Now usually adapter sense when the DC inboard is good is 3 volts. That's 0.7. That's bad. That's not good. 0.7. So that could be a bad DC inboard as well. So it's very possible that the charging port is fried and it's not actually passing through what's needed for my MagSafe. So I'm going to go and grab another DC inboard. I'll be right back. I'm going to take a trip over to the other side of the store. It's actually far enough away now that I can call it a trip. Like I actually have to make a trip to get a DC inboard. Hi-Hi's in the front of the store. Should we pull a trick on Hi-Hi? He's He's staring at me suspiciously. I think he knows. I think he's on to me. Uh-oh. There's a gross DC inboard in my... And there's a semi-gross DC inboard. Oh, what the... Okay, that's hysterical. Okay, what am I gonna do here? I just grabbed the wrong DC inboard, didn't I? I sure did. Okay, be right back. Sorry, people. Be right back. Gotta get the right DC in. Put an A1425 DC inboard in there. Absolute bastard. How's your cat, David?
He's a cat.
You don't have a cat?
No.
How did you get through the screening and the job interview process here?
I have a cat.
Okay. We're going to... Okay, it's my test charge port, and as you can see, now we are getting it to take an amp, which is correct. And if I were to measure voltage, you'd see the adapter senses a proper amount. Adapter sense is now 3.3 volts. This one wire is 3.3 volts, which is what I'm expecting it to be. On the schematic, you would see, so when the bad charger went through, it actually killed my DC inboard, so it was only sending 0.7 volts in adapter sense rather than 3.3. Likely wasn't able to communicate anymore. So the bad charger that was plugged into this machine destroyed not only the charge port, but it also killed the charging regulator chip, U7000. It killed its current sensing circuit and shorted that. This wound up getting shorted to ground. Yeah, this over here wound up getting shorted to ground. Pins 28 and 27. And these resistors in the current sense circuit died. But now it works. It has a spinning fan. It'll be able to charge a battery. And that just does kind of suck. That a bad charger can cause all of this. A little bit of money saved on the charger can cause a lot of money to have to be spent on the fixing of the rest of the computer when that dies. And just because I'm a nice guy, and I realize this is going to be back here in a week, if not less, with crashing GPU problems, because this is a 2012, early 2013 Retina, I am going to reflow his U8900, because if I don't reflow this, it will be back here crashing in less than a week. I know it. So this, you can see that from several of my videos about the 820-3332 board. Had a little Apple recall that didn't last for long. You didn't get it fixed by 2016, you weren't eligible. And even if you did have it fixed by 2016, well, you still, it would have broke again. Let's be real here. We're going to do a little bit of mild reflow over there. And when we do that mild reflow, we're going to make sure that we use the appropriate amount of flux. There is a fuse on the charger line, Mani Katan. There is a fuse. Does anybody know what the right amount of flux is? Yummy Steaks is paying attention. I'm noticing that in the chat that Yummy Steak is paying a lot of attention and getting a lot of right answers. Yummy Steak, are you in the business or do you just watch a lot of my videos because you don't have much else to do? I'm curious. Nice try, little bridge. I'm sorry to hear that. I hope that you were able to make a full recovery, and I hope that you're feeling better. I'm glad to hear that you learned something from watching all these videos. If you don't have a job, and you want to live in the absolute garbage hole dump that is New York City, keep me in mind. You seem to know your stuff, and you seem to be able to answer my questions very, very quickly, and you seem to be good at predicting what's wrong with the board. At this point, the motherboard is going to be ultrasonically cleaned. The machine will be reassembled, and then it will be tested to ensure that every other function works. But that's a process that I do off video because it's highly boring to most people. So you got to watch a video where I fix the board, and hopefully from that video you were able to learn something. If you were able to learn something, then I'm very happy, and I hope that you continue to watch and continue to learn. I'm sorry that I haven't had as much time recently to do these videos as I have in the past, when I would release board repair videos on a much more regular schedule. I've made some interesting life choices and some interesting business choices that have really kind of deprived me of much of the time that I used to allocate to those things, and it's resulted in less of that stuff being produced, which I'm not particularly happy about, but I don't know, I feel like I'm a bit existentialist in that when there's an opportunity, I think there's an opportunity, I kind of just ride with it and see where it takes me. And I've been doing that for a long time. Some days I'm happy about it. Some days I'm not so happy about it, like when I started the stream. But we'll see what the rest of the year holds in store for me and what the future holds in store for me. And we'll see what the future holds in store for all of you. Hopefully more fixed and working MacBooks, more happy customers, people with their data back, people with machines that work, and people who can have that little yes feeling when they see that the fan spins and the light turns on and everything works. That beautiful feeling of accomplishment that is particularly unique to component level board repair industry that we're in. That's it for today, and as always, I hope you learned something. I'll see you all in the next video. Bye now. See you later. Cut! Alright, we're off camera. Fuck all those people. I can't believe we have to make videos for all of them. What a bunch of pieces of shit. Oh. Oh, you're supposed to stop streaming too. Hey, everybody. Oh, I love you all. Oh, I'm fucking with you. I was. All right. Get ready to go deaf with some ultrasonic cleaner noise, people. I'm going to make you all deaf right now. Nice ultrasonic noise. Ready for some beautiful ultrasonic cleaner noise? Yeah, that's right. Very funny, reported unsubbed by. Johnson Como says we're in the group that already know you hate us. Don't worry. Still. Are you writing off 2020? Yes. This is going to be a shit decade. I like how a lot of people... have been saying that I can't wait for 2020 to be over. Man, wait till you see the rest of the fucking decade. Do you know what the rest of this decade is going to be like? You got people that are completely and utterly desperate, that have nothing left to lose, there's tons of businesses that just got completely and utterly destroyed, and the people that work for them or the people that own them lost what they worked for 10 or 20 years, and now we're starting at the bottom again with no help, no assistance, no nothing, and they're, people getting kicked out of the house they've lived in for 15 or 20 years, and all because of shit that wasn't even really necessarily their fault. Oh man, a government that is going to try to make up billions of dollars in deficits by becoming more aggressive with taxation, more aggressive with fees, more aggressive in every single way. I was watching this one Joe Rogan show. I forget who it was with, but he was going over I forget if it was the Ferguson thing or Michigan. I forget which one, but it was this one police shooting, and they said like the whole reason that a lot of people were pissed off already, it wasn't even like the specific details of the shooting, and the people that go into the specific details are missing the point. It's that that particular police department and government was using their citizens as an ATM. So, like, they were already, finding all these kind of bullshit reasons to give people tickets and fuck with them. So by the time something real actually happened, there was no goodwill. There was nothing left. Because they had, destroyed and spoiled all the goodwill by, fucking their citizenry on a regular basis with the constant stops and fees and everything. So that's kind of what exacerbated a lot of the distrust in police in that particular area. And that was before we had all the clusterfucks of budget deficits we have now. So what I'm really kind of interested in is once things are forced in some way, shape, or form to return to some semblance of normal, when bills finally start becoming due, what the hell do we do about the fact that, like, oh, your city has a $20 billion budget deficit, and all these people are now unemployed and can't have no taxes to pay? Well, what are you going to do? I don't know what the answer to that is, but I realize the next 10 years, the next 10 years gonna suck. The next 10 years, next 10, 20, 30 years are gonna be shit. And here's the thing about being a pessimist. Have I mentioned this already? I try to mention this almost every day. The best part about being a pessimist is that when you're proven wrong, when you're incorrect, it means the world is a better place. Being wrong as a pessimist means that that the world is actually better than what you thought. So being wrong as a pessimist is one of the coolest things in the world. And I hope I'm wrong. I really hope I'm wrong. It would be nice to be incorrect there. But the bills are going to come due. The bills are going to come due. It's probably going to be a war of some sort. A lot of war happens because of a shitty economy. Probably be a war of some sort. I'm kind of curious who it's going to be with and how they're going to talk us into it, though. That's what I'm kind of curious about. I have a feeling there's going to be some sort of war. But you have to have a pretext. It's got to be somebody that we already hate, but like we didn't hate them enough to go to war with them, but now we're going to like magically hate them enough to go to war with them. You know, it's going to be something where this group has been terrible for this long, but now we care about it. It's going to be something. Don't know what it's going to be. Don't know when. Exactly. Probably China or Russia. The Middle East thing is kind of getting tired and boring. But there's only so many times you can bomb the same place over and over and over again before it just starts to feel like a rerun. Like when I watch the news and I hear that there's another drone strike or whatever somewhere in the Middle East, I just think to myself, like, well, you know when you watch an episode of Seinfeld or something when you were a kid and you were excited to see that there was a new episode that's supposed to be out, and then you see a clip show and you're like, God damn it, that's a clip show. For those people in here who are so young that they didn't grow up on regular television, a clip show is when you're expecting to see a new episode in a series, and instead of a new episode, they come up with some bullshit premise to just show you a bunch of episodes from like 5 years ago. Like they, you know, everybody meets at a party, and then or they get stuck in an elevator or some shit, and then they start recalling old times. So they're literally, it's pretty much a way to avoid having to come up with actual content. And every time I see the news with that stuff, I just kind of feel like, is this a clip show? Because I think I've seen this shit before. Like we did that already. Oh, we're still doing it 18 years later. Fun. But I got this really cool ultrasonic setup now where I have the Branson EC that's heated to 60 Celsius with this distilled water. After it goes through that, I spray it off with this little alcohol bottle of 99% isopropanol. Then it goes into a Tupperware container of 99% isopropanol just to get rid of the water. And after that, it goes into an ultrasonic that is only alcohol, unheated, but just 99% alcohol. And I've noticed that the boards come out looking a lot cleaner. Like when you do that, when instead of just going Branson, then alcohol, then drying, Branson, then alcohol ultrasonic, and then drying, it comes out looking like factory. Hell, I'll damn near say, I'll say it comes out looking better than factory, because this is beautiful. Just gonna have that thing get cleaned, leave some notes in the ticket. I'll eat some food. I think I've earned some food. After I eat some food, maybe I'll read some of your chat. Maybe I won't. Maybe I'll read it if it's not the Twitch chat. That's a conspiracy I need to keep feeding. That I don't read the Twitch chat. That the Twitch chat are second-class citizens. Alright, let's walk back to the table, see how many people are triggered. Get ready for my food. Close the door. ITC Extreme, why is it so hard to find you? You know how many times people ask me, like, for a person in the UK that does this stuff, and, like, I Google you? It's virtually impossible. So I just give people your name and kind of make it their problem to tell me where to, you can find them. Good luck with you trying to find them. Erica packed me lunch of 2 gigantic bags of gummy bears. You know what? I deprive you of the food cam today. Big companies losing money where the essential workers are losing their mind. Show how countries prioritize stuff. I think a lot of people are losing a lot of everything. It's also kind of interesting how the government has kind of mandated that Amazon become the primary store for a lot of people. Because if every business in your town is closed, you're kind of forced to go to Amazon. So even if Jeff Bezos didn't really want to become any richer, it's kind of like the government just looking at, he's like, listen, man, can you become, listen, I know you're worth 100 billion or so. We need you to be worth $1 trillion. Jeff Bezos is like, nah, $1 trillion, listen, I only, 150 to 200 billion is good for me. I don't need to be worth $1 trillion. It's like, no. You don't understand. We need you to be worth $1 trillion. Let's shut down every other store. Jeff Bezos, you are not killing retail fast enough. You need to be killing retail faster, Jeff Bezos. What are you going to do if you get drafted? You seem like a healthy male. Screw that. We would overthrow our own government before a draft happened in America in 2020. Like, we're not for that. That era is done and gone. Of people who live in the U.S. being willing to blindly get transported to another country and start shooting people they don't know. That's gone. That is gone. That was a different era. That was before the internet, before all this other stuff. You can't do that now. If they tried to draft normal people, I'm pretty sure that our government will wind up getting overthrown from within, rather than losing a war. Someone said war with Russia or China is apocalypse stuff. That's the thing. I would completely agree with you. Like last year, at the beginning of this year, I would 100% agree with you. The entire world economy is currently in the toilet. Excuse me. The entire world economy is in the toilet. And people across the world in every country have not really felt the full effects of just how fucked they are. It's like they can see the storm cloud ahead, but the lightning hasn't struck them yet. Ah, hello, Wolf Girl. How are you doing, sir? Kind of hungry. Lewis knows that condenser mic puts you right between his teeth.
Why am I here says sticker link isn't working? I will ask Kai how to fix that later. Who am I kidding? I'll forget to ask Kai how to fix that later. I'm not using an Aeron chair, Nitro. I'm using some cheap Amazon shit. Some knockoff Amazon shit. I don't get it, Wolf Girl. I really don't. Fame is confusing and weird. What do we say we move on to another board? One thing's for certain. Regardless of how screwed the world is, it will be that much more screwed for you if you sit by and don't do something about it to make sure that your place in it is further away from the eventual blast. You can always move yourself forward. Because me, I try not to get down seeing that the world is going to shit. Things that I don't like happen. I try to keep doing what I do. I try to do it better with each passing day. I try to deal with what I can control. Why not replace the components you don't have access by patch PCB with components you have access? What the fuck? Okay, I don't know what the fuck that means. Alright. Rip YouTube, indeed. I just need to leave a note, and then we'll move on to the next one. Excuse me, I'm sorry. We're going to grab another machine momentarily. Can't see your chat right now. Sorry. Have to rename my video file as well to get prepared for the next one. Be right back.
I fucked up and I made it. What's next? Hey everybody, how's it going? Today we're going to be working on yet another MacBook motherboard. This is an A1466 that the customer says doesn't turn on. This is a MacBook Air 13-inch from between 2015 to 2017. We're going to turn on the power supply software. Gives us a good old-fashioned 10 milliamps, but doesn't turn on. We're going to take the board out and see if we can figure out why it doesn't turn on. Maybe it'll make itself obvious. Maybe it won't. The transistor video that helped me was Krista Packrat was from a YouTuber called Steel Wheels Down, who unfortunately is now deceased. It's a small YouTube channel. I think it has like 1,200 subscribers or something. It's called Steel Wheels Down. He had a good video. Quality video. Don't you hate it when your chair runs over your MagSafe cable? Yes, I do. Some question why the gloves. They're not latex, they're nitrile. And they're here because MacBooks are often nasty, and I like being done with my work and taking off my gloves and my hands having some semblance of being clean. I just kind of prefer it that way. That's all I'm going to put there. Just kind of prefer it that way is all.
pressure on anything while you're on top of the battery. Okay, we're going to have this MacBook board on the desk, and we're going to figure out what's wrong with the MacBook board. Are you all ready to follow along with me? Perhaps you can follow along with me and see what's going on. Yes, here we go. We're taking 0 milliamps, 69 milliamps, and then nothing. 69 and nothing. 81 and nothing. All right, what that's doing, folks, is it's power cycling or boot looping. And there's usually a reason for it, often related to a short circuit. So we're going to say if we can find out what that is. Unfortunately, when we look at the board, it looks completely clean. There's no hints whatsoever, and when you have something like this, it really does help to have hints. But we don't have any hints here. We don't get any. Let's check a couple of basics. PP342 is present because we have a light on the charger. Check. 8.6 volts. SMC is doing its thing. 8.6 volts on PP bus. PP bus is jumping. That is strange. Definitely strange. I'm not used to seeing that. I don't think I've ever seen that on this one before. PP VRTC G3 hot is 3.3. All right. PP5ES5 is 5. But it goes up and down. You can tell the whole machine is looping. Okay, so that usually happens when there's a rail related to the TPS 51980 chip that is shorted, and we're going to go through our list of rails and figure out if any of them are shorted. Are you guys going to follow along with me? Hope you are. You can open up a schematic for an 820-00165 at home. And you too will be able to kind of go through and figure this all out. We're going to look through our list of power rails. The first thing I'm going to do here, I'm just going to go down the line and measure them. PP5ES5, not shorted. Okay. Then the question then becomes, is PP3V3S5, which is also created by this, shorted? PP3V3S5 can be found up here, according to the schematic in the board view. That's not shorted. All right, we're just going to go down every single line. That's what we're going to do. PP3V3 S4. Search. PP3V3S4, 68 kiloohms. It's not that. PP3V3S3 then. Let's see what that's doing. Can measure PP3V3S3 over here. According to my schematic and board view. 63 kiloohms, that's not it. Alright, PP3V3 underscore SO. It's going to be this one on the top here. 3.6 kiloohms. Alright, so it's not the 3.3 volt line that's doing it. Alright, PP5ES4RS3. PP5ES4RS3 is 0.5 ohms to ground. See? PP5ES4RS3 is on my list of power rails. On the schematic, the list of power rails is going to show up right over here around page 62 on this old model. So I'm just going down the list over here and I'm measuring my rails. So usually, you have the G3 hot power rails. Those are the rails that always need to be on, even if the computer's not on at all. Always on. Like, for instance, charging the battery. The battery, that's a rail that's always on because you never know when it always has to be on for just in case you hit the power button. It's always going to be there. S5. S5 are power rails that are only on when the computer is off. S4 rails are rails that are on when the computer is hibernating. S3 are rails that are on when the computer is sleeping. So, for instance, the RAM power rails would still need to be on even if the machine is sleeping, whereas the screen would not. SO, that's a power state for when the computer is on and fully functional. You know, you're browsing the web, watching a video. That's where you'd need, let's say, CPU vCore in addition to RAM. The CPU's got to be on. You would need your backlight for your screen and so on and so forth. Now, to get to here, these rails have to be present. So what we have here is a machine with a short on PP5V-S4. And I went through the power rails pretty much one by one. So PP3V3-S5, then S4, then S3, then SO. PP5V-S5, then S4, then S3, and then SO. And here, this is the chip that's responsible for creating many of them. This is responsible for creating PP5ES5. Now, PP5ES5 is jumping up and down, but I'm not going to troubleshoot that because that rail, if you take a look, when I measure where PP5ES5 would be, 17 kiloohms to ground. That's not my problem. My problem is PP5ES4. It's that. So the rail above it being shorted is actually causing that to not work. Because as you can see, if I check up U7501 in the schematic, the same the same chip is responsible for all those rails. It's responsible for PP5ES4. It's responsible for PP5VS5 over here. Probably can barely see that. And it's responsible for PP3V3S5. So if any one of those rails is not working and it's shorted, it's going to shock that entire chip and keep it from doing its job. So now we got to figure out what is shorted on PP5ES4. So what I'm going to do is I'm going to go over to my schematic in my board view, and I'm going to click on PP5ES4, and we'll be able to see everything that's on that line. So one of those things that has a leg on ground is going to be shorted. Let's see if you can tell me which one it is. Which one looks broken? This doesn't look broken down here. That cap doesn't look bad up there. Chip itself that creates it looks mighty fine to me. This cap looks okay, as does the chip under it. Alright, and we're going to have a group of 3 caps over here. And those caps all look just fine. This cap is probably not going to reveal itself to us unless we give it the OWI test. So what I'm going to do is I'm going to put a wire over here on the board, and I'm going to inject some voltage into it, probably just a volt or so. Keep it low. So let's say one of the transistors for one of the other power rails is shorted. It doesn't wind up sending 5 volts into a 1 volt line or a 2 volt line. Just going to inject a little bit of power there and see what gets hot. And then we'll hopefully you got the catch of that. Hopefully you got the idea behind what was going on. When you saw in the beginning how the power supply was showing us 80 milliamps, 20, 80, 20, 80, 20. It was trying to turn on but failing. That's what it was telling me. It's trying to turn on but failing. And usually it's going to turn on, oh my god, I'm shorted. Turn, oh my god, I'm shorted. It's going to see that short circuit and turn off the entire circuit. That's what was going on. And that is what gives me that first indication that what I have is a short. So before I even went measuring, before I even found the short, I knew that there was going to be a short because of what my power supply was telling me in the very beginning of the video. Okay, so something's going to be getting hot soon. Now we're going to perform the OWI test because for some reason every time I hook up the damn thermal camera in my office, it winds up turning my internet off and ruining the stream. I don't understand it. Something should be getting warm. The OWI test will tell us, though. The OWI test always does. You can always count on the OWI test. Sometimes it may take a little bit longer than you want, but the OWI test is foolproof. Okay, it's definitely one of these three. Definitely one of those three caps over there. Now, which one is it? All right, so I'm going to turn off the power that's going to the board right now. I'm going to scoop a little bit of alcohol onto those three caps. Remember, all those caps, if you take a look at the schematic in the board view, all those caps are for PP5E S4. Any one of them could be the one that's shorted. But which one is, so what we're going to do is we're going to see which one is getting the hottest. So I'm going to scoop some alcohol on top of them, and then really quickly I'm going to go back to my power supply and turn it on, and we're going to see which one it comes off first. You ready? 1, 2. It looks like it's the right one, but it's barely evaporating. It's like evaporating at such a slow speed that it's kind of hard to confirm that that's it. Let's do it one more time, but with a little bit more, teeny tiny bit more. Yeah, it's the right one. Now you can actually see it vaporize. Okay, so at this point we're going to take the wires off, and I'm going to relieve the short by removing that capacitor that is clearly bad. And you notice how this presents differently from the PP bus short that we showed in our other video, right? I know. I usually use alligator clips for this, but my alligator clips broke off, so I soldered straight to the screw hole. So now that screw hole has a little half moon, it's going to be a sign that I was there from now until the end of time. So okay. Suck up that little solder blob there. All right. I left a minor scratch there in the PCB, but oh well. Forgive me. It's a good luck scratch. Someone suggests I check if the short is gone, but I'm a betting man. I am a betting man. You made me doubt myself. You bastard. Tried to get away. The dot goes on the top. You try and get away and trick me? Wait, don't go on upside down. I was wrong, here's 5. I forget what you were wrong about, but I will take your $5. Rapid cool technology. My power supply software is on crack. It's not even connected, and it thinks that I'm using 4.3 amps. It's not even on, and it thinks I'm using 4.3 amps. The board has now been rapid cooled. So we're going to do this. We're going to do this. We're going to do this. And it's going to take 600 milliamps, like a champ. You what, mate? You what? You what? You fucking what, mate? Did I put the cap back on the right orientation? Oh, come on. Come on. Oh, fuck you. Fuck you. Fuck you. Not fair. Why is PP Best going up and down again? Okay, you're a steady 8.59. Steady 8.59, steady 26 milliamps. What, there's more? There's more? Really? Okay. Steady 26 milliamps means PM sleep is low. PM sleep being low means that this... No! You fucking what? Of course. Is PM sleep gonna jump up and down for me? Jump up and down for me. Jump up and down for me! not jumping at all. 5 volts. So there's no more short. And there's no more PM sleep? The fuck? What? No. It's not fair. I fixed your problem. You can't be missing PM sleep now with no pulsing. It's not right. PM DSW power good. Are you there? Where's my PM DSW per good? 3.4. Okay. RTC signals. RTC is there. F in the chat for Paul's Q. You know where this is going already. The short is gone. I checked already, but even in addition to checking, it's not boot looping. The boot looping was the problem. What if the cap died and it took U7501 with it? That doesn't sound believable. Because you have PP3V3S3 and PP5VS5. I mean PP3V3S5 and PP5VS5. Okay, it takes a while to stabilize to 26 milliamps. What the fuck? Why? 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 Let's check PP5ES3. Yeah. Maybe that's short at the ground. No shorts. PP5ES3 and PP5ESO. No short. No short. What if we change the transistor and the TPS 50980 just for the fuck of it? Because that's the closest thing that's near PP5E S4RS3. That's the closest thing. That's all I got in my head. PP5ES4 also goes here. This chip is also gets PP5ES4 as an input. I'm assuming that everything that had PP5ES4 on the line got screwed with. So what's that strange blue stuff? Didn't mean to put all that solder in the middle. Lol.